Welcome everyone to this week's IVI Coffee&Talk. We're delighted to have Dr. Peter Mooney here to speak to us about APIs and how they can be enablers for digital transformation. And Peter is our colleague here in Maynooth. He's based in computer science in the Hamilton Institute, and he's also in the ADAPT Centre as well. So I'll hand over to you, Peter.
Thanks very much, Grace. And yeah, it's a pleasure to be here virtually, and so yeah, a very close colleague geographically in the same building, and this is my first IVI talk, and today I want to share my slides, so they're still visible, I hope. Yeah, great. So I want to talk today a little bit about application programming interfaces, APIs, and how they provide a role of being enablers of digital transformations and also allowing for innovation to happen, both in research, in industry, and in governmental settings. So I'm not always, I don't take for granted that everyone knows what an API actually means, and an API is an application programming interface. So it's essentially a collection of code, of software that sits between the internet and all our devices and some kind of knowledge or data store. So as you see the diagram on the slide in front of us, the API sits essentially on a web server, and using your mobile device or your web browser or a smart device such as an Internet of Things device, data and other resources from databases or something within a company or within a governmental agency can be accessed in some kind of a controlled way. So there are APIs everywhere, and if you asked yourself the question, have I used an API today? You may say no, but if you've been on the internet at all today in any way, if you've used a smartwatch or a smartphone, you've probably used at least a dozen APIs unknowns to yourself. The best analogy I've found and heard of for an API is one of a restaurant, and the restaurant analogy must include a kitchen, a waiter or a waitress in this case, a menu and a customer. And the idea is that the kitchen is actually the data store in this analogy. That's where all of the resources are. That's where all the data is maintained. The waitress here in this case is the API, because it's their job to interface between the users, who are the customers here, and the kitchen, the data store. And of course, the data and information, I suppose, that is delivered to the user is in the form of the food and drink that we see here. So the API, in this case, the waitress, plays a very, very important role in that they enable the transformation of what happens in the kitchen to be delivered to the end users. And without the API working, that connection and that transformation simply would not be possible. So going back to a more serious look, APIs are now as more than ever, and API as technology are probably on the scene 40 years, if not 50 years. As soon as internet connectivity was available and there was software able to interface between internet connected machines, APIs were a way of connecting. And the European Commission have been very proactive in this regard over the last couple of years, particularly in looking at how APIs have a role for data governance, but also the idea of digital coordination. And when we say digital coordination, we mean the increased digitalization of society. There is a need to connect all of those nodes up together, and the nodes are different but they're all part of that ecosystem. So we have government agencies, we have industry, we have SMEs, we have citizens, and we have Internet of Things, we have AI, etc. So all of these are different nodes in this digital ecosystem. In terms of the governance, APIs perform a number of important tasks. Again, going back to the analogy of the previous slide, controlling what is moving from the kitchen to the users, but also controlling access. And APIs can, and it's probably a conversation for another talk, are a cybersecurity concern, because they're essentially the doorway into the digital infrastructure for any organization. So they have immense value in enabling digital innovation, but that must be balanced against the possibility that they are the shop window and they are the access point into your digital infrastructure. And there was a really great explanation in a previous IVI Coffee Talk by Dr. Hassan, and I'm using his diagram, which is a diagram from another paper in 2020. And I'm borrowing this because Dr. Hassan was talking about European data spaces, and the need for us to somehow find a line of best fit, really, for the high dimensionality of the problem of digital innovation. We have lots of data sources that are different entities, that are different structures, different models, and we have different data sources which have different levels of popularity. And of course, there is different costs then around the administration of those data sets, the administration of APIs, the delivery of digital access to these data sets. And as the diagram shows, there is a need to try and find a nice spot, a best effort approach there. And that's very often what APIs ask us to think about, is that the API technology is very mature, but trying to find where it best fits for an organization does take a little bit more extra effort. Because what I have in the slide in front of us there is two examples from another report by the Commission on API use within governments, why, what, and how. And what we see here is, I suppose the bottom of the slide is the best part to start the explanation here, is that we have different agencies, such as the Meteorological Agency or an Air Quality Agency, who are obviously gathering digital assets in real time, and then real-time observations become historical observations, which are all very valuable, and they become digital assets in different ways. Each of these agencies must have their own APIs, which serve particular types of API consumers. And the end product for many of these governmental APIs are indeed citizens, because they are the end users of these applications. And summarizing the examples there, we see that we have roles and we have products. We have the digital asset themselves, the API provider themselves, the customers, or the consumers, excuse me, and then the applications. And the quote from above is from the report below, is that APIs are playing a fundamental role in this digital transformation. So I can remember maybe not so long ago, maybe 10 years ago, where access to assets such as environmental data was not always possible via an API. It was a much more multi-stage process. You had to make contact with the agency in question, and then you had to somehow build a relationship with them to the point where data was then made available to you on a CD, or maybe made available to download as a large file on the internet. In subsequent years to that example, the governments have taken on a much more proactive approach in delivering APIs. And the API framework tool is something that's used by those agencies and industry to see and self-assess themselves around their own use of the framework. And what we see here is an emphasis on platform, on people, on processes, and on policy. Now, the rest of my talk is going to, I suppose, emphasize platform, but no matter what way we discuss the API framework, and even if we only take one slice of this framework, it's not possible to talk about it in complete isolation. But the next part of my talk, the remainder of the talk, will focus on the platform. So just permit me to go back to the restaurant analogy again, but just with a little bit more detail. And in reality, and in an implementation sense, APIs are multi-layered complex systems. And because of that complexity, they are subject to issues that need further investigation and constantly need configuration and surveillance by the organization, the company, etc., that are implementing the API. So we can have problems such as too many users. And in that case, then the API, the waitress again, is not able to process the orders because there's simply too many people. The menu may not fit the requirements. So the API is available, but the users are finding that the API does not deliver what they're looking for. So the queries, essentially, that the API provides are not fit for purpose or fit for use. Another example is where the waitress simply cannot keep up with the response request timings. So it's unable to bring the data from the knowledge stores behind the API to the users. And maybe the actual databases in the background does not have the required data, or it takes too long to somehow query and process and load that data. And as we'll talk about at the end, semantics are an issue, that users may not be able to communicate with the API, or they may not understand the data that is retrieved from the API. So this brings me on to a project that I've just recently been involved with the Joint Research Centre of the European Commission on looking at a very specific part of the problem we talked about there in the previous slides. Is in a practical sense, when we look at APIs in the classic client-server approach, most responses for APIs today are provided in the default de facto kind of standard of XML, JSON, CSV, and in a GIS, or a geographic information system approach, shapefiles. There's many issues with this, and they are summarized as issues around the preparation of the queries and the responses, the loading of those large responses, etc., etc. And I'm going to go into detail about one or two of those. Now, this project is available. The QR codes are there. Will bring you to the report and also bring you to the software that was written to do these tests. And we are going to concentrate on three of these, where the API is unable to handle requests due to the size of the request. The API is unable to deliver the request efficiently and quickly, and maybe it's taking the kitchen, or the database in our case, too long to create the response required by the user. So what we did in our experimentation was we went about looking at typical geospatial innovation workflows. And when we say typical, we looked at what most GIS practitioners, both in government, research, etc., do when they access data. And they usually access data from APIs in two ways. They They get access to a very big file, a static file, or they download directly from an API in real time. So what we went about doing was comparing the performance of standards such as JSON, and GeoJSON being the geographic extension of JSON, to binary approaches. And binary approaches generally are used quite widely in the scientific world, in metrology and in astrophysics and some of those domains. And the idea is they will offer smaller file size. It will be quicker to package the response and send it to the clients, and it would be quicker to unpackage or deserialize that data. Now, in the report, we have the details of this, but to show you a real-world example, if you're familiar with the OpenStreetMap database, OpenStreetMap provide dissemination of all of their data in several formats, but one of them is a binary data format. To support this very different approach to access to data, there are a number of openly accessible software libraries and schemas that allow other agencies and users to actually come up with their own software solutions to loading and processing a binary data response. So it is very much possible, but there are very few examples of it in real world digital delivery. And some of the results that we have from the report, and the report has more details, is that we do find that the binary files are indeed smaller than the static file and indeed the JSON files. So that's good news for the delivery from the APIs. In terms of the processing times, we did find that there was little difference when it came to the static file, the large file that was downloaded. But we did find a significant speed up when we were considering the APIs, an API response in GeoJSON. So just to summarize some of the key results, is that one of the negative aspects for some people is that the binary data will always need a schema describing the data provided. JSON and GeoJSON do not need that. They also require specialist code. So there's lots of library support in programming languages today for JSON and GeoJSON, but special code is required for binary. However, we can avoid any vendor lock-in in the software. So that provides very good support overall. But the problem is, as an organization changes their underlying data models, the schemas will need to be updated. So that is an implication for this approach. And just in red, I just want to point out the first bullet point there, and to emphasize it, that it's still a challenge for us to measure and understand success. So we've seen examples where the binary approach for APIs is better, but whether that represents success in terms of a whole organizational approach is something that requires more investigation. And something that I am very interested in is in looking in future work on this is around semantic interoperability. Because of that very mention before of the schemas, one of the problems might be that we have to keep exchanging these schemas because we have to keep delivering the semantics, the meaning, the details of the data with the data we provide. And while interoperability is a very much a multi-pronged approach with open data, with open source technologies, etc., the ability for data portability and reusability is driven by semantics. So the government, for example, here in Ireland, in a recent strategy, shows this interoperability platform. But I think that the key will be when we get down to ensuring that all of these are indeed interoperable. So my final slide, and apologies maybe for the small text here, but I'm really interested in some of the recommendations from the recent interoperability report, and in particular, it's looking at information strategies that are best suited to dealing with issues around semantics, around delivery of data from APIs, etc., and how that can best use open specifications and open source software. So I'd be really interested in some collaborative work maybe on looking at how companies and SMEs, etc., can increase innovation opportunities with the implementation of this interoperability framework. And thanks for listening and watching.
Thanks very much, Peter, for a really interesting talk. I'll open up the floor to any questions, comments, feedback for Peter.
Yeah, I can start. Thanks, Peter, for your talk. Very interesting. And a couple of points. First of all, going back to your analogy of the restaurant, and when you have the customer and the waiter, and the customer is asking for something to the waiter, of course. To me, APIs that are kind of more are created for technical people, for people who are created. So that to me, it would be like a customer is asking not really for a dish, for something cooked food, but more for the raw ingredients. That so that from the kitchen, so that he's asking, and then he will just combine the ingredients and cook the food that he or she prefers, something like that. Because at this point, and this would be the first question, so that if you think that APIs have a future also for being used by people who have are not technical skill, I mean, not programmers or something is like when, for example, you were also referring to open data. Of course, you can have the open data sets, but you have also some visualization tools or something that even if you are not an expert, you can still look at the open data from, let's say, practical application point of view. So creating some kind of basic application so that you can still use the data. And of course, if you want to combine this data with other information or creating application, of course, that's something else. But at least there is a basic use. So APIs can work at the same time. And the second question about the interoperability, integration, linked data also, that, for example, there is linked data that are the linked open data, so that is kind of the highest level of openness in data. So also you can have integration at the data level, you can have integration of the API, so that, for example, when the user just takes data, the API, for example, creating an ontology that combines the different data. So there can be the data itself that are just combined in with this one ontology, or you can do through API, or you can do at the user level that you just take different data. So that where do you see that what would be the best, let's say, the best position where to create this linked data and the interoperability among data?
Great, Marco. Thank you. I suppose to go back to the first point, I think it's a really great point you make, that currently a lot of APIs provide a very set menu that the user must choose from, but they can't get access to the raw ingredients to make their own dish. And I think we are seeing some examples using things like Sparkle and other technologies where the query interface is provided for the advanced users, and then they can query in quite a free way, so that they can move outside what's on the pre-delivered menu. And then, as you said, there are some visualization tools for users who are not so familiar with APIs. And I suppose from a technical point, providing that ability to query for the advanced user is very valuable. But of course, the more of these ways that are provided, probably the more resource intensive it is in terms of both the expenditure, the technical know-how, and it's probably getting to know your user base as well as you can, so that you know that if I provide an advanced interface, that it will actually be used rather than something that just is a couple of users every year. I think the second point on interoperability around linked data, I think the big challenge there is the fact that many organizations, while having very modern approaches, are still relying on a lot of legacy systems, and that data has been stored and managed in the same way for quite a long time. And I think what they will need is better examples of how to make that jump into linked data, for example. So how would an organization that has a particular data set actually go about making it semantically interoperable? They're pretty good at probably doing the syntax interoperability, but the semantics, so it probably needs more examples, more use cases, and a clearer explanation of what's required from the top down within an organization, because it is a big challenge for organizations to take on. Thank you.
So we're actually just at about 2 there, so we're going to wrap up. But thanks very much again, Peter, for your presentation.
Thank you very much. Thank you all
for the session today. And as Peter shared there at the end, this is just a reminder of the different places you can keep in touch with us. Next week we won't be having a coffee talk because it'll be St. Patrick's Day, but they'll be back the week after, and we'll be hearing from Dr. Fabiano Palinetto, who is the cluster lead for the Sustainable IT cluster here in the IVI. And also keep an eye on those channels for information about our upcoming webinars. Our next webinar will be focusing on data governance, and that is coming up at the end of this month. So thanks everyone for attending, and hope to see you all here again soon.